Hey guys, welcome back to my garage. In this video, I'm gonna change out the DC motor controller in this D&M4 machining center that I converted to Acorn some time ago. It's based on the Sherline mills, and it's got a DC motor in the spindle. You can turn the spindle motor on and off with this toggle switch when the controls are running, and then you can vary the speed with this potentiometer right here. This is the DC spindle controller that we'll be using on the project. It's a KBIC 120. It's 115 volts input, and its output is 0 to 90 volts DC. It's rated at 6 amps DC without a heatsink and 12 amps DC with a heatsink. So it can control, I believe, up to 1.5 horse motor, DC motor. Another thing about this is it requires this SI5 signal isolator board to work with Acorn. The 0 to 10 volt analog input signal from Acorn will come into this, and we'll be able to control the spindle using Acorn. The other thing about nearly all these KBIC drives is there's a horsepower resistor right here, and that resistor must be sized to the maximum horsepower of your motor. I'm going to take the cover off the spindle motor so we can take a look, see if there's any clue as to what horsepower it might be. Okay, so we'll go ahead and take these screws off. There's a couple things that we want to know is we want to verify the motor's max terminal voltage. We got those screws off. Okay, here's our DC brush spindle motor, and you can tell it's DC brush because there are brushes on either side of that motor. And as we look around here to the label, might be hard to see, but it says it's 110 volts DC, so that's good. Now, if this motor were 70 volts DC, that's something we'd have to take into consideration. We would have to turn down the max potentiometer to limit the output voltage of the drive. The other thing is, if you don't have a label on here, you can take a meter, a DC meter, and put it on, and then flip it on, put it on high speed, and measure the voltage coming to the motor. Let's see if we can do that. Okay, what I'm going to do is I'm going to put my probes on the inputs of the motor, black and red over here, and you'll be able to see on the display here what the RPM is, or you'll be able to see on the display here the max voltage. So I'm going to go ahead and turn the motor on and crank it all the way to high. So there we're getting about 80 volts. So that's well within the ability of the KBIC control. The motor, it says on the label, 110 volts DC, so we might even get a little bit more speed out of it with the KBIC control. So that's the first thing that we're going to do. The second thing we're going to do is we're going to just take a quick peek at motor RPM. Okay, before we start, I want to show you this digital tachometer. It's really handy to have if you're working on stuff. You can find them on Amazon for less than 20 bucks. They're cheap, but they work okay. Here's what it looks like inside. Comes with some reflective strips, which you need. You cut a little piece of this and you put it on we're going to put a little piece on the spindle here, and then we're going to use the tachometer to read the spindle speed. And it'll be interesting to see what we get now versus what we're going to get after we do the conversion. So let me get that piece of reflective material. There it is right here. And I'm just gonna, if I can get it apart, I'm gonna stick it on the spindle. Okay, let's measure the RPM. If you can see, that's about 2,500 RPM. Okay, so the next part, I'm going to go ahead and remove this old DC controller. Let me bring you down to that and we'll start taking it apart. Okay, first let me explain a couple things. I do have power turned off. I'm going to go ahead and disconnect the cord so power's off. And obviously right here is power in, white and black. This next one here is to the motor armature. This one is to the switch that's on the front, and this is to the potentiometer. So I won't need these anymore, but I will reuse them most likely because they're heavy enough. We can get the analog signal from Acorn to the drive. But for now, I'm going to go ahead and remove this and get it all out of the way. I was trying to figure out who the maker is of this DC controller. I don't see any maker's markings, no company name or anything on it. Some dip switches here, jumpers and so forth, but no maker's markings on it. I don't know, maybe if one of you guys recognizes it, you know, shout out and let me know. There's the model number. All right, well, I'm not going to bore you with mounting up the KBIC drive. I've got to move the standoffs and make it fit the drive, and I'll do that off camera. Okay guys, I got the KBIC drive mounted. One thing, I've got the power resistor in there. There was no amp rating on that motor, so I went to Sherline's website and I found out that the old motors are rated for a 0.5 horsepower. It's marked right on here. You can get it from KB Electronics, eBay sellers sell them, but you got to make sure you put the right resistor in there. So that's plugged in. The other thing I want to call your attention to is you have to put fuses in on this drive. Hope this turns out. Okay, you have to put, here's L1, L2, there's L1, L2, there's A plus, A minus. You have to put a fuse, so AC is going to go through the fuse and then goes to L1, and then the neutral will go to L2. And then on the armature, you'll see A plus is going to go through a fuse, and then it'll go to the armature, and then A minus will come back from the armature, which is the motor right here. Okay, so I'm going to go ahead and get those fuses installed. Now, the KB drive has threaded holes on either side of it for these type of fuse holders. So I'm going to go ahead and mount those up really quickly. Actually, probably easier to put these in before mounting the SI5, especially this one over here on this side. because it's pretty tight down in here. So this one's going to come around to line 1. And then the AC minus, go into line 2. This is line, and this is line. So what I'm going to do here is I'm going to go ahead and put a quick disconnect . Here and here. Give it a tug, make sure it's in there all the way. And then the female end, I'll put on this one here. Okay, I'll go ahead and plug those two in. So now we got power going to the fuse. Still have to put fuses in, mind you. But now we got power going through, going into the line side of the fuse. Load side of the fuse is going into the drive, and neutral's coming out. Now we've got to worry about the DC motor. And DC motor is going to be very similar. Here's the fuse holder for that. Okay, let's go ahead and get this fuse holder in. Again, this is for the armature side. That's the armature negative side. Here's armature positive side. Okay, so that's done. Now we've got to put a quick connect on this one and this one. Got a tug, make sure it's good. Okay, connect that. There's that. And we need to put some fuses in here. And the manual. Take a look at the KBIC manual for fuse sizing. Okay, if we select the fuses now, there is a chart in the manual. Hopefully you guys can see that, it doesn't wash out. But we have a 1/2 horsepower motor, so we want a 5 amp fuse on the DC, and we want an 8 amp fuse on the AC. So I'm going to go ahead and grab those. Okay, I've got, let me double check here. This is 5 amps, so that's the DC side. And this one is 8 amps, that's for the AC side. Boy, that one's going to be a bear. There we go. All right. So we got our armature hooked up. We've got our AC power hooked up. Now we've got to get our 10 volt analog signal from Acorn over to our signal inputs, on the KBIC. So I'm going to go ahead and reuse this piece of cord cable that goes to the switch up front. I think this will make it really good. It's nice and heavy, and you want to use at least 18 gauge wire to get the analog signal from Acorn to the drive. So I'm going to go ahead and get this threaded out of the machine, and then we'll hook it up. Okay guys, so I've got the drive mounted. I've got it all pre-wired. Now we're going to wire up some signal wires. So we need the 0 to 10 volts analog signal from Acorn, and we're going to need a contact closure from Acorn to inhibit the drive. That means so that when there's no spindle speed called for, the spindle doesn't turn. If we don't inhibit the drive, because of the way the analog signal works is we're going to set a minimum speed and a maximum speed in the wizard. We're going to want to at least run this drive, minimum speed probably 300 RPM, and then we're going to see how fast we can run it with this with the new KB electronics. So because we're running at a minimum speed, we want a way to inhibit the drive. That means turn the DC Spindle Drive off, and it has an inhibit circuit. So first, let's take a look at the analog signal input connections to the KB drive. All right, we're going to be using this one right here, input signal 0 to 10 volts. So it tells us to use SIG, SIG, and common. So this is the one we're going to use. So let's do that first. Okay, I've already routed the wire, the cable, and here it is. Here's this end right here. So we're going to run this to SIG, SIG, and common is right next to it. Okay? See if I can zoom you in a little bit closer so you can see that. Okay, so we wired it to SIG and common. Red is signal, black is common. Okay? Now let's go up to Acorn's analog output. Okay, there is Acorn's spindle output. It's right to the left of the beagle bone green, and it's just below the DB9 encoder connector right here. Now, on the board itself, it says that this terminal is common and this terminal is voltage. So I'm going to go ahead and connect those. And of course, the power, everything is powered off. You don't want to do any of this hot. You risk the chance of damaging something. Okay, double check. Common voltage, and then again down here, and then again here, signal and common. So we've got our 0 to 10 volt analog, spindle analog output wired to our SI5 signal isolator board. Okay, now the next thing to do is the inhibit circuit. Okay, here's the inhibit circuit. So it goes from I1 to F minus. And you'll see when it's closed, it stops. Okay, we're going to go from I1 to F minus, and then we're going to use the relay on Acorn. We want this relay on Acorn to be wired to the normally closed. When it calls for the spindle to run, Acorn will open that relay and it will enable the drive. So let's go ahead and get that hooked up. Okay, I've got a piece of cable right here, and we want to go from I1 to F minus. Here's I1. It's always a good idea to solder your wire tips too. I'll go back and clean this up. Okay, there's I1 and F minus. And there's I1, there's F minus. Now I'll reroute my wires later, but let's go over to Acorn. Okay, here's the terminal block for Acorn. It has these two relays on here. This one right here is basically an e-stop relay, so that's used. This one right here is available, it's not used. So we're going to configure this one in the wizard to be spindle forward. And what we're going to do is we're going to use terminal RL2 and NC2. So that when there's no spindle called for, this circuit is closed and it will inhibit the drive. So I'm going to go ahead and put that in. So we're going to go with RL2, it's relay 2. And we're going to go to NC2. And it's always a good idea to use shielded cable too, by the way, guys, for these signals. And I'm out of the 2 conductor stuff, but I wanted to go ahead and get this video out for you and show you how to hook it up. Okay, we've wired the black to RL2, which is the wiper of the output 2 relay, and we've got NC2, which is the red, and that's wired to normally closed. So now it would inhibit this drive when we power it up. All right, let's go ahead and power it up. Let's configure the wizard CNC 12 to use output 2 as spindle forward. Okay, let's go ahead and configure CNC 12. We've got to configure that output 2 for spindle forward. All right, right down here where it says output 2, we're going to click on the box and we're going to search for spindle forward. There it is. All right, so that will, when we make a call to turn on the spindle, that relay will open that inhibit circuit to the KBIC drive. So let's go to spindle setup. All right, it's right now it's set to 300 and 4,000 RPM. We had 2,500 RPM before, so let's see if we can get 3,000 RPM out of it on the high end, get an extra 500 RPM because our motor says it's rated for 110 volts DC. So let's give us a little bit of cushion, but let's see if we can get 3,000 RPM out of it. So I'm going to write the settings. Okay. Okay. We'll close it. Let's go ahead and open up CNC 12 Mill. All right, I'm going to go ahead and home my machine. All right, let's see if our spindle works. I'm going to go up here on VCP to Auto Spindle Manual. I'm going to click on it. And now I'm going to go ahead and press, let's go ahead and set this to 100%. So it's the middle. You'll see right here under spindle speed it says 1,500 RPM. So that's what it should run at. We've still got to calibrate the spindle. So I'm going to hit the green spindle control button. And our spindle is running. Let's see if we can bring it spindle speed down. Okay, we can bring it down. Let's see if we can go up. That's 3,000. I'm going to bring it back to 100% so we can measure the spindle, the voltage going to the spindle, and see where we're at. Okay, what I want to do is I'm going to go ahead and calibrate the drive to our spindle speed. So I want to show you where the 2 pots are that we're going to be working with. This one right here says minimum, and that's our minimum speed. And over here, you can just make it out in the corner. It says max. This is our max speed spindle pot. So we'll be working with those as we adjust things. All right. Okay. I've got my probe wires on the motor. You can see in this picture. I've got the meter here, and then you can be able to see everything that we're doing here, hopefully. So I'm going to start with the low RPM. So what I'm going to do is I'm going to put CNC 12 right there is auto. When this LED is lit up here in the top, right here, when that's lit, it's in auto. I'm going to put it in manual mode. So I can touch my screen, and then I'm going to put it, let's go ahead and leave it in the minus, which is the slowest speed. And now we're going to go ahead and start it, and we're going to observe the meter voltage. That's going to be the DC voltage to the motor. And then I'm going to use the tachometer to check the spindle RPM at the same time, see what we're at in the minimum range. So let's go ahead and start it. And I don't hear anything, so I'm going to take it up a little bit. Okay, so that tells me that our minimum speed needs to come up right away. So I'm going to put it down. I'm going to run it back down to 300. You see right here it says 300, and I'm going to start raising the minimum pot until we start getting some movement. Okay, so now we got movement. Now I'm going to use my tachometer. Until I'm at 460 right now. I'm sorry you guys can't see it, but I can do it all, show you everything at once. So I'm dropping it down to 300. Went a little too low. Okay, I'm at 292. Okay, there's 311, so that's close enough, I think, right there. Yeah, that's 311. All right, so that's the bottom end. And you see at 300 RPM, we've got 11 volts showing on the meter. So now we're going to go ahead and go up. We're going to watch the meter. Remember, the terminal voltage, according to the label, is 110 volts DC. This drive is capable of going up over 90 volts. So we're going to run it up and see what we get. So now I'm going to go to 100%. I just clicked 100% on our spindle override. We're at 61 volts. For giggles, let's see what that RPM is at right now. 1960 RPM at the middle. So I think we're going to have to tune this down a little bit. I'm going to go a little higher. I'm watching this. We don't want to exceed 110 volts. There's 95. Let's see what 96 volts is giving us. Okay, 96 volts is giving us 3150. So I think what I want to do, because at 3150, the spindle is at 3150, but you see spindle RPM says 2300. So what I'm going to do is I'm going to drop this down a little bit. And I'm going to go to the maximum pot, and I'm going to reduce it. Because what I don't want to do is go too high and go over that 110 volts and chance ruining the motor. So now we're going to go back up. We're going to see if we get 3,000 RPM without going over, much over 90 volts. Okay, if you look here, we're maxed at 3,000. We're at 89 volts DC right here on the meter. You see that? So what I'm going to do now is I'm going to take the tachometer and I'm going to hold it to the spindle, and I'm going to reduce or raise the maximum pot on the KB drive until we get 3,000 RPM. Boy, we're really close right now. We're at 2946. Could almost leave it right there. Let's see if we can eke it up just a little bit. All right, that's a little over 3,000. See if I can drop it a hair. Oh, too much. Need to make a change and let it settle. got 3,011 RPM right there. Okay, and we're maxed. So you see, I used the max speed pot to get us where we needed to be. And you see right here we're at 91 volts DC, which is pretty safe. So I'm going to drop this back down to 300 RPM and see if we're still at 300 RPM. May have to go back and forth a little bit here. Yeah, our minimum is got to come up. Very finicky here. I got 301. Now let's go back up to 3,000. Not bad. $3,005. Didn't have to turn it very much. Let's look at the bottom again. $300 there. $287. This might be as close as we can get it because it's too finicky. It's too hard to turn those pots. $3,001, 3,000. Let's see. 3,017 RPM. Now let's hit it right in the middle. That should give us 1,500 RPM. You see right here? 1,500 RPM is what we want to get now. See how close we are. We are right on the money, 1503. All right, let's put it back in automatic mode. I'm going to stop it. We'll go back up here to auto spindle. Let's go ahead and put it back in automatic. It's in automatic. Let's go to MDI, F3, and let's do an M3S2000. That should turn the spindle on when I hit cycle start. I can hit the green button here. That should turn it on and run it at 2,000 RPM. (2,006 RPM, fellas. Now let's go to an S1000, S1, 1, 2, 3. Let's hit cycle start. You can see up here we've called 1,000 RPM. I'm hitting it with tachometer. 993 RPM. That's dang close. 990, yeah, 994 actually. That's where she's at. Let's do S500. Cycle start. $493, $494. Let's do S2500. Cycle start. $2518. Go ahead and shut it down. We do an M5, M5, and then cycle start. Shuts it right down. Alright guys, I hope you enjoyed this little video of me swapping out that DC control out of this Sherline based CNC mill. It's a D&M4, but it used a Sherline mill for its basis. And then I retrofitted it with Acorn. It's running a Gecko Drive G540 in drive only mode. I have no limit switches, so I just jog the axis to where I want, and then which is basically the extremes, and then I set home. And you know, because I had the KBIC drive and the SI5 the signal isolator, I decided to go ahead and put it on this machine. I'm actually getting ready to sell this machine. I also put a little fourth axis on it. Let me run you over there and take a quick peek at that. There's the shot of the little axis drive. I actually got this unit off of eBay, and they're still selling them. They're about $107. It's a little rotary stage, and then I got this chuck off of eBay as well. It's a 2-inch chuck, and I machined and armored and so forth. Anyway, it seems to work pretty well. Let me show you. I'm just jogging it with my Shuttle Pro. So anyway guys, I hope you enjoyed it. I just thought I'd take a little extra time to set it all up and let you watch me change out that DC drive, how it gets hooked up to Acorn. You know, some of the precautions that need to be taken. Obviously did everything powered off. Hooking up the analog signal from Acorn to the SI5 drive, and then wiring the inhibit circuit from relay 2, which is output 2, to inhibit the drive unless the spindle is called on. So anyway, I hope you enjoyed it, and I'll see you guys on the next one. Take care and have fun.